Okay, picking up here, part two of this experiment. We're about to get into the meat of this. I think hopefully this has made sense to you. This is what you should have filled out so far. And we're talking about regular shapes down here where all the sides are the same and all the angles are the same and everything's balanced. All right, so yes, this is a square. I know we call it a regular quadrilateral, and I know you would rather call it a square. Okay, so let's go on and do this pentagon. All right, a pentagon has 5 sides, so this is some reviews for some of these things for you. And the number of diagonals formed, so this is what's happening here. I am going to draw in a diagonal from one vertex. I'm picking one vertex, and I can draw in 2 diagonals. And again, I'm going to do this one more time, but I'm not going to do it on all of them. This one has 3 angles that are 180. These 3 are 180. And these 3 are 180. And when you take out the diagonals and you're left with 6 and 8, and you add them together, and 3 and 5, and all of them added together, that should be 180 times 3 triangles. So this pentagon is going to add up to 540 degrees. Okay? 540. So let's fill this in. I had 2 diagonals. It formed 3 triangles, and 3 times 180 is 540. All right. And by the way, the reason you don't put a bunch of diagonals in there like this is we don't care about those interior. We're only working on these angles out here on the exterior. Okay, so that's why we only draw in diagonals from one vertex. Okay, so let's do this. Since there's 5 of them, let's divide that by 5. And we just learned that each one is 108 degrees. And let's label it. Then, let's do our exterior angles. A linear pair with 108 is 72. All the way around. Let's go ahead and make this look pretty. We may stop doing this at some point. I want you to get the idea. We're talking about all these exterior angles. Okay, so each one is 72. And if you have 5 of them, well, let's see what 72 times 5 is. It's 360 again. All right, I hope you're noticing something here. Okay, let's go on to the hexagon. A hexagon, I believe this is my hexagon right here in the middle. It has 6 sides. All right, when I draw in these diagonals, 1, 2, 3, I got 3 diagonals, which creates 4 triangles. So 3 diagonals, 4 triangles, and then here we go, 4 triangles at 180 each is 720. So pentagons are going to add to 720. And then if I have 6 of them, if it's regular, that means each one's 120. So I can go to putting that in the corners. All right, each one of these is 120. Let's extend these out here and start thinking about the exteriors all the way around. Linear pair makes that 60. So that goes there. And then if I have 6 of those 60s, the sum of all those, again, would be 360. Wow. So here, let's take a little observation. What's happening here is when I sum the interior ones, it's continuing to grow and get bigger. And each interior is actually getting bigger. Each exterior is gradually getting smaller. I don't really see a pattern there. But this is a little bit odd that the interior are growing and the exterior appear to be staying the same. Okay, this is true. That is the way that's supposed to happen. Let's do a heptagon. A heptagon is a 7-sided figure. Hopefully you're getting caught on to the idea now. So this is my heptagon right down here in the corner. It's going to create 4 diagonals are going to create 5 triangles. And I think you're starting to figure out the pattern, because this is the part I want you to remember. What am I doing if I have 5 triangles in there? Well, it's 5 times 180. So this sums to 900. All right, sums to 900. And then the other idea here is to take that and divide by how many angles there are. Well, there's 7. So 900 divided by 7. And we do get an ugly decimal on this one. A heptagon is just not very pretty. This is correct. We could call it 128.6, just to round to the nearest tenth. All right. And so that means each of these is 128.6 down here all the way around. I won't round them all in now. We'll extend these and look at the linear pair. Well, the linear pair with 100 is 51.4. And if I have 7 of those all added together, you're going to get to 360. I know I got negative on there. Ignore that. Okay, so 51.4, and they all do add up to 360. When you carry out all the decimals, it works. Let's do another one. Octagon. One more that we'll draw on down here. Octagon. Here we go. We know an octagon is like a stop sign. I've got 8 sides. I can draw in 5 diagonals. I can create 6 triangles. 6 triangles at 180 each would be 1,080 degrees. So this is continuing to grow, and I have 8 of them, so I'm going to divide by 8, and I get 135 for each one. So there's 135. And then I can draw in the exterior. A linear pair with that would be 45. So this would be 45. And if I have 8 of those, let's just double check. 45 times 8 is 360, just like we thought. And we're going to continue on, and we're not going to go forever, but we'll do a few more here in the calculator, and then we're going to talk about a formula, which is the most important thing at the end. All right? So that's going to be 9. We know this is going to be 10. Let's see. This is going to be 6 diagonals. It's going to create 7 triangles. So here we go. 7 times 180 is 1260. 1260 divided by 9 is 140. So this is going to add up to 1260. Each one is going to be 140 if it's regular, which means the linear pair with that would be 40. And if I have 9 of those, it would make 360. One more time for a decagon, we would have, let's see, that would be 7 diagonals, create 8 triangles. So here we go. 8 times 180 is 1440. So we're getting kind of large here on our numbers. And dividing that by 10 is 144. Linear pair with 144 is 36. And then if I have 10 of those, of course, that's going to add up to 360. Okay, here's the most important part. What can we say overall for any polygon, that's any n-gon? And we do run out of names at some point, and we just call them a 14-gon or a 15-gon or a 16-gon or maybe a 100-gon, like whatever number is going to go right there. All right. So the number of sides is going to be n, however many sides it is. Okay. And this is where you're going to have to look for some patterns right here. Not just that that's going to increase. This isn't going to be 8. How is this column right here related to this column? If you'll look all the way down, they differ by 3. So whatever this number is, you subtract 3. And the triangles formed, it's always one more than that one. However, look at it related from the number of sides to the number of triangles. If I have 7 sides, I have 5 triangles. If I have 9, I got 7, 10. It always differs by 2. This is an important column right here, the number of triangles formed. All right. And then this is our big formula that we've been discovering right here. This is what we're working to discover. To get this number, what did I do in my calculator each time? I took this number times 180, and I got that. I took that times 180, because this is 5 triangles at 180 each. 6 180s, 7 180s. So it's this number n minus 2 times 1/8. This is an important formula right here. The sum of the interior angles of any polygon. This is a big deal right here. This is kind of one of the main reasons we were doing this. All right. And then what was I doing to get this formula? This number, you can go ahead and take this one and divide it by n, because that's what we were doing. We're taking 900 and dividing by 7, 1080 and dividing by 8. So I could write me another formula up here. N minus 2 times 180 divided by n. We don't use that one as much. These out here, you want you to think about these going backwards, because this formula starts to get ugly. But what we do know for any polygon, we've discovered this, they do add up to 360. And so the easier way, now that we have discovered this other fact, which is our other most important one, now that we've discovered this, we can take this idea and work backwards. So if I had a 20gon and I knew there were 20 exterior angles, I really just have to do this number divided by 20 to get it. Because see, look at this, 360 divided by 10 will give you 36. 360 divided by 5 will give you 72. I know I've got n exterior angles, so I'm just going to do 360 divided by n. And that'll tell me each exterior angle, if it's a regular figure. There we go. This is the big idea. Those three columns right there with the stars by them. You need to know how we evolved to get this. So just filling out the chart is not going to do it for you. You need to experience where we came up with those numbers, and I think you'll remember it.